Alright, hello everybody. We are going to be looking today at the Chapter 8 review on exponential equations. um, if you look at the review, the first four questions are asking us to match up the equation of an exponential function to a particular graph. So we have to use what we know about the structure of exponential equations in order to, I don't know why that happened, in order to match these up, okay? So if you'll remember, you can compare these to their parent function, and we know what their parent function looks like. The parent function always goes through a particular y-intercept, and it always has an asymptote at 0 if it's growth, and if it's decay, same thing, it's just turned upside down. It looks something like this if it's decay, and it goes down to 0. So the what we're going to want to do here is we're going to want to look at each of these and look at the transformations and determine if it's growth or decay, and that should be enough to tell us which one of the graphs we're looking for. Okay, so if we look at number 1, the b value here is 3, which is larger than 1, so this tells us that this is a growth graph. Okay? The plus 1 up top, that tells us that the graph has been shifted by the left 1 unit. And this minus 3 down here tells us the graph has been shifted down 3 units. So we're going to be looking for a graph where the asymptote has been shifted down 3 units and that it's a growth graph. Okay, so if we look at letter A, the asymptote's actually up here at 3 instead of 0. This is a shift up by 3 units. Okay, so that's clearly not going to work. Even though this is a growth graph, it's been shifted up by 3 units, not down, because it's up here at 3. So letter A is not going to do it for us. So let's take a look at letter B here then. Letter B is also a growth graph, so this one is growth as well. And we can see the asymptote is down here at -3, which is where we need it to be. That's a shift down by 3 units. There's no other graph. There's only 2 graphs, so if we look at letter C, now we have a good idea. This could be letter B, okay? This could be letter B. We look at letter C and D. These are both decay graphs. Okay, so it's definitely not C or D, and it was not A. So number 1 is actually letter B. So we know B is taken, so let's keep that in mind as we look at the next one. So number 2 is almost the exact same. Well, not really, but it's got a lot of the same things. So if we look at the 1/2, this tells us that it's decay. Any number that's like a fraction or a decimal is decay. The -2 here tells us that it's been shifted to the right 2, and the -3 here tells us it's been shifted down 3. So we'll be looking for a graph that's been shifted down by 3 units, and that is decay. Okay, well, we can eliminate the first 2 options, A and B. A and B are both growth, and we already used B, so it's not A or B, it's either C or D. So if we look at where the asymptote is for C and D, the asymptote for C is up here at 3, which is a shift up by 3 units from 0. But that is not what we want. We want to shift down. Well, if we look at letter D, D is decay, and it has a shift down by 3 units because the asymptote's down here at -3. So letter D is the one we're looking for. So number 2, that's letter D. So B and D are both taken. All right, number 3. Number 3, the 3 here means this is growth. The +2 here means this is shifted to the left 2. And the +3 here means it's shifted up 3. So we'll be looking for a growth graph. We know that that's either A or B. Those are the only 2 that are growth because they go up on the right-hand side. That's either this one or this one. We already used B, and if we look at letter A, we can see that the asymptote for letter A has been shifted up 3 units. So we're going to be looking at letter A for number 3 here. And we only have one option left, but I'm still going to go through it here. So letter number 4, the 1/2 tells us that this is decay. The +2 tells us this has been shifted left 2. And the +3 tells us this has been shifted up 3 from the parent function. Remember, all of these transformations, left 2, up 3, they all apply to the parent function, which is the function that occurs without those two things. So decay, letter C and D are the only decay options, and we're looking for the one that's been shifted up 3. So you can see here that our asymptote is at 3 instead of 0. So this is decay, shifted up 3. So letter C is the one we're looking for here for number 4. Okay, so for number 5, we are looking to answer a couple of questions about this exponential function here. This is the right-hand side is going up, so this is of course growth. The domain is all real numbers, okay? Because remember the domain tells us what available x values we have. So we can see if we continue this graph to the left and we continue it to the right, every x value shows up, -8, -7, -6. So we measure it from the left side to the right side. So the left side is negative infinity, the right side is positive infinity, so we say the domain is from negative infinity to positive infinity. Now the range is measured, letter C, the range is measured from the bottom to the top, okay? Instead of the left to right, it's measured from the bottom to the top, okay? So if we look at the bottom of this graph, it goes down to -4. That's actually the asymptote here. It goes down to -4. And if we follow the graph up, it goes up to infinity. Okay, down to -4 here and up to infinity. So we would say the range is an interval between -4 and infinity. This is the bottom, this is the top, and we just put parentheses around it to show that it's an interval. The y-intercept, well, we can see that's right there. Okay, so that's the point 0, -3. The asymptote is this horizontal line that the graph gets very close to but does not cross. We can see that this horizontal line goes through the y-axis at -4. So this is called y equals -4. That's the equation of this line, y equals -4. Okay, very important to remember it is y equals, and an easy way to remember that is to look at where it crosses through. It crosses through the y-axis at -4. So it's y equals -4. The next two we have are word problems, growth or decay models. So you remember we have equations that we use to set this up. We have growth model, which is y equals a, which is the initial value, 1 plus r to the t. And we have our decay model, which is the same thing, but instead of 1 plus r, it's 1 minus r. Those are two models that we'll be using here, growth and decay. So we just need to, as we read the question, figure out if it's growth or decay. So David put 2,000 in an investment account that increases in value 4% every year. So this is growth. And the R value, which is the rate, is 4%, but we got to divide that by 100 to make it a decimal. So 0.04 is our rate here. Just divide the percent by 100. So to set up our equation, it would look something like this. So here's our initial amount, here's our A value. So 2,000 multiplied by our factor, which is 1 minus, 1 plus, because it's growth, 1 plus the rate, 0.04, and that's raised to the t power. Okay, well, we don't want to leave the factor as two numbers. We should simplify that by just adding them together. So that's 1.04 to the t. And this is our answer for letter A. Letter A says write a model, and this is the model. Letter B says use the model. Okay, so we're going to be plugging in a number for t. So use the model to determine how much the investment is worth after 15 years. So t is 15 to calculate this. So 2,000 times 1.04 to the 15 power. This is something we can just easily and quickly plug into the calculator. So 1.04 raised to the 15th power, multiply that by 2,000, and we get $3,601.89. So that would be our answer for letter B. Number 7 is similar, but this is a decay problem, as we'll see in a moment. A new car costs $23,000 and its value decreases, so here's our A value, decreases by 13.5% each year. So we need to divide this by 100 to get our rate, so 0.135. And then we have to use our decay model because this is decreasing in value. So the decay model, 23,000, whoops. So we're going to write the decay model, letter A, 23,000 multiplied by 1 minus, because it's decay, 1 minus the rate, 0.135, and that's to the t power, whatever that is. Okay, let's simplify the factor here. I want to know what number is in the parentheses there. So 1 minus 0.135. It should be a number between 0 and 1, because it's decay, and it's 0.865. So this is our model, our answer to letter A. Now let's use that model, letter B, to calculate the car's value after 10 years. So I'm just going to plug in 10 here, 0.865 to the 10th power. All right, so let's do the exponent first, 0.865 to the 10th. Multiply that by 23,000. So we get $5,393.73. Okay, so it's lost quite a bit of value over the time period. All right, number 8, these should be pretty familiar to you. We just did these yesterday and the day before, so we're going to be solving these exponential equations. So first we need to set the bases equal to each other. So for 8 and 2, we can use a base of 2. So 8 becomes 2 to the 3rd power, and that's raised to the x power. And then the right side already has a base of 2, so we can leave it as it is. We do have to multiply these. So 2 to the 3x is equal to 2 to the x plus 1. Now that the bases are the same, we can set our exponents equal to each other. So 3x equals x plus 1. Subtract x. 2x is equal to 1. Divide by 2, and we get our solution that x is equal to 1/2. So for letter 8, x is equal to 1/2. Number 9, 5 to the 3x plus 1 equals 25 to the x plus 1. We can use pretty easily, we can use a base of 5 here. So 5 to the 3x plus 1, and then 25 to the x plus 1, but 25 would be 5 to the 2nd power. So we want to use a base of 5 for both. We don't need to simplify the left side, but the right side, we do have 2 exponents, so we do need to multiply them. So 2x plus 2. Now that the bases are exactly the same, our assumption is that the exponents must also be the same. So 3x plus 1 equals 2x plus 2. We can solve this. Let's move the x's to the left side. So x plus 1 equals 2. Move the 1 to the right side, and we get x is equal to 1. So our solution for number 9, x is equal to 1. If you plug x into both of these, if you plug in 1, both sides will be the same number. Number 10, we got 1 over 81 to the 2x plus 1 equals 9. So we want the base here, and we want to look at the bottom number to get the base, because remember, when we're dealing with a fraction, the only thing we need to consider is that the exponent will be a negative number instead. Okay, so if 9 and 81 can both be expressed using a base of 9. So 1 over 81 would be a base of 9 to the 2nd power, because 81 is 9 squared. However, we have to use a negative exponent to make it a fraction, so 9 to the negative 2nd power. And then it still has the exponent of 2x plus 1. The other side, you might be confused because we don't see an exponent here. However, if we don't see an exponent, there is an invisible exponent of 1. So we got to keep that in mind when we're setting them equal to each other that the exponent on the right side is 1. Multiply these. So negative 4x minus 2, and that's equal to 9 to the first power. And now we will set our exponents equal to each other. So we got negative 4x minus 2 is equal to 1. And we can now solve this. We add 2 to both sides. Negative 4x is equal to 3. We divide by negative 4, and we get x is equal to negative 3/4. And this is our solution for number 10. Number 11, 8 and 4. So 8 and 4 can both be described using a base of 2. So if we look at 8, so the 8 is now going to become 2 to the third power. On the other side, we look at the 1/4, and we know that it's a fraction. So we know that 2 to the second power is 4. Okay, if you raise 2 to the second power, you get 4. But we want 1 over 4. We want the 4 in the denominator. So that means we need a negative fraction. So instead of 2 squared, it's 2 to the negative second power. All right, now we have to multiply these exponents. So we get 2 to the 3x plus 12 equals 2 to the negative 2x. Now that the bases are the same, we can set our exponents equal to each other. So 3x plus 12 equals negative 2x. All right, now in this one, it might be easier to bring the x values to the right-hand side, but we don't have to. So I can add 2x to bring this to the left side, and that will give me 5x plus 12 equals 0, because there's nothing left over there. I can subtract 12, and that gives me 5x equals negative 12, and I can divide by 5, so that gives me my solution, negative 12 over 5. Okay, a lot of these will be fractions, that's not a problem, so yeah, negative 12 over 5. And then our last problem, number 12, we want to sketch the graph of this exponential function. Okay, so we could do this two different ways because we learned two different ways. We could just make a table, all right? We could make a table and fill out the values in the table and then sketch this. And if that's easier, then we can do that. However, I would like to graph this using the parent function. So let me think about what the parent function looks like. Okay, the parent function would be without this and without this. So it would just be y equals 2 to the x. So if you remember, the parent function can tell us three things. It tells us if it's growth or decay. Our b value is growth here. It's 2, so it's growth. Now our a value should be in front of the 2. Okay, if you think about the 2 having parentheses, our a value should be in front of the 2, and that's our y-intercept. Remember, y equals a times b to the x. The a value is the y-intercept. The b value is the growth or decay number. So the a value here is actually 1 because it's not listed, it's not written down. So our y-intercept is going to be at 1. And we also know the asymptote of every base function, every parent function is at 0, y equals 0. So let me just do a sketch of my parent function. So my asymptote's here. I know that it's growth. And I know that the y-intercept is at 1. Okay, so it looks something like this. Now, that is my parent function. That's not the one I'm trying to graph here. This one has the two transformations. It has the -2 and it has the +3. So those two numbers are going to move this around a little bit. It's going to move the asymptote and it's going to move the y-intercept. Well, it's going to move the whole thing, but those are the two things we're going to move. So the -2, that moves it to the right by 2. The +3 moves it up by 3. So I'm going to move this graph around to match that. Okay, so the asymptote is no longer at 0. It's actually moved up here to 3. And our y-intercept is no longer at 1. It's actually moved up by 3 as well and moved to the right by 2. So it's actually right here. Now it looks like it's on the old graph, and it might be, but I doubt it. Okay, so let me get rid of the old graph, and let me use the fact that I know that it's growth to sketch the new graph. So the new graph would instead, it would look like this. It would be a growth model, and it would go through that point right there. Something like this. Something like this. So this, we can get rid of all of this. This would be the graph of y equals 2 to the x minus 2 plus 3. This would be a good enough sketch. Since the problem says to sketch it, this is good enough. We could have also done this using a table, okay? You could have done this using a table of values, an XY table of values, putting 2 in the middle, and plugging in all the numbers, okay? You could have done it this way. This would be fine as well. This is acceptable to do it this way. I just personally think it takes more time, but you could do it this way. All right, that's it for the review. I hope that was helpful. Good luck on the test, everybody.